Hello everyone, I hope you guys are doing well. Before watching this particular video, please follow example number 1 and example number 2 on big O notations. In these particular lectures, I have explained big O notation with two different examples. So now let's have an example of lower bound. Again, I have f of n. F of n is equal to 5n plus 4. Like this is our function, and n value is 2, 3, 4 and 7, let's suppose. It should be in the descending order. So this is our, we have to find the lower bound of this function. So the existing function is f of n is equal to 5n plus 4. So what will be the condition? It should be greater than or equal to, c g of n upon a positive constant, like n should be greater than or equal to n naught. This is the condition. So this is, again I will say, this is a constant, and this one is your f of n, so g of n. So you have 5n plus 4 less than or equal to, so what I can write it here? I can write just 1n, okay, 1n. So if I put values in that, 5n plus 4 less than or equal to 1n. So if I put 2 in that, so the condition will be true. 5 into 2 plus 4 less than or equal to 2, okay. So this will be 14 and this will be greater than or equal to 2. So the condition is true. So if I put 3 over here, so its condition will be true. If I put 4, if I put 7, so the condition will be true. So we can get a graph like that. This is your f of n and this will be your g of n, c g of n. This will be your c g of n. So again I will say it's not optimized. I can write, so what is this function? I can write this definition in a asymptotic notation. Like I can say, according to this definition, because this is cg of n, I can write omega of n. So again it means that the lower bound also belong to this part, okay, this class, or this you can say this function. But if I put the n under the root here, if I put here n under the root, like not here, if I put n under the root here, again the condition will be true. So I can write it omega of n under the root. So if I put, so it mean that this under the root it also belong to lower bound. So if I put log n here, so the condition will be again true. If I put 1 here, the condition will be true. So it means that this part including n, it's belong to this part, it's belong to the lower bound. But I will again recommend that please keep, like for example, if I have 5n plus 4 greater than or equal to, so if I keep 8n here, the condition will be false. The condition, because it is multiplied with the n, and here the 5 is multiplied with the n. So I should keep like this doesn't work. So I can write 5n. So if I write 5n, so 5n, the condition will be true because here 4 is added always. 4 is always added, so the condition will be true. If I keep, so if the 5n will be more optimized as compared to 1n. So keep in mind that whenever you try to find the upper bound and lower bound of a given function, so try to find optimized, try to find the close value to that particular function, the particular given function. So this is all about the lower bound. We will have few examples later in next video.